Okay, last problem that I'm going to do on the final exam review is number 15, and of course final exam review would not be complete without a projectile problem. So we have a projectile shot from the edge of a 100-meter cliff. So here's my cliff. It's above the ground with initial speed 30 meters per second at an angle of 30 degrees relative to the horizontal. So there's my V initial. Okay. And then I'm going to make my coordinate axis. I'm going to put my origin down at the bottom and say that's x and that's my plus y. This is theta. So I know V initial equals 30 meters per second. I know theta equals 30 degrees. I know my y initial equals 100 meters. And what else? I think that's about it. So let's actually, when I do these, I like to break it up into my x variables and my y variables, so we don't get confused. Okay? So projectiles, we're always going to be working with the distance versus time formula. So we want to know what's x final, what's x initial, what's v initial x, what's ax. And same thing for y. What's y final, what's y initial, what's v initial y, and what's ay. So the projectile is going to, follow some parabolic path to here. We don't know what x final is. Okay, so we don't know that. We do know x initial is 0. We know the x initial velocity, right? We have to break that initial velocity into its components. So we have v initial at an angle of 30 degrees. This is v initial x. This is v initial y. So this is v initial cos theta, right? Because here's my theta. And this is v initial sine theta. Okay, my acceleration in this class, we're always just going to do acceleration 0 in the x direction, and it's negative 9.8 meters per second squared. And the y, because I said plus is up, right? So gravity is always pointing that direction toward the ground. So according to my coordinate axis, it is negative. Okay, y initial we do know is 100 meters, and we also know that y final is going to be 0 meters. Okay, so I think we have everything there. So we need to find, right, so we don't know t. We don't know x final. It goes in here too. Okay, but part A was to draw a sketch. Part B is to find out what the time is. So pretty much, when you're just doing a straight projectile problem and it's launched, you gotta hit the ground. It's the y equation that you want to use to solve the time. Okay, so we have y final minus equals y initial plus v initial y t plus 1/2 a y t squared. Okay, and since we end up with an initial velocity, we're going to get a quadratic, but we don't need to be afraid of those. So we want to solve for t, right? So let's get it in the form of a quadratic. So we'd have 0 equals y initial minus y final plus v initial y t plus 1/2 a y t squared. Okay. So when we're plugging into our quadratic, right? You've seen it before that y equals ax squared plus bx plus c. So the squared term is this, right? So that's our a variable, that's our b when we're going into the quadratic equation, and that's c. Okay, so let's plug in. So we have y initial minus y final, which is 0. So this is just 100 meters. We have v initial y is v initial times sine of 30, right? Sine of 30 is just 1/2. So this is actually 15 meters per second times t. And then we have 1/2 at squared. So 1/2 times 9.8 is 4.9. So we get minus 4.9 meters per second squared, t squared. Okay, and now we have to use our quadratic. So t equals negative b plus or minus the square root of v squared minus 4ac all over 2a. Okay. So what the heck, let's just plug in. So this is my b, so we have negative 15 meters per second plus or minus 15 meters per second squared minus 4 minus a, which is negative 4.9 meters per second squared, and then c is 100 meters all over 2a, which is going to be negative 9.8. Okay, so let's plug in to our calculators, get all that figured out. You're going to find two roots. One of them will probably be negative, and that corresponds to, all we're just solving for is the equation of this parabola, right? So it's going to hit the ground back here, but that's before the problem starts. So that's our negative time. We want the positive time out here. So you should get that t equals 6.3 seconds. Okay. All right. So that was just part B. So C, how far does it land from the cliff? C. So we need to find x final. This is not so bad. So we're going to use our x position versus time. So x final equals x initial plus v initial xt plus 1/2 axt squared. So right away we want to cross out anything that's 0, like our initial x, and our x acceleration is 0, so that whole term goes away, right? Because anything multiplied by 0 is 0. So this is pretty easy. This is x final is v initial x times t. V initial x is 15 meters per second times cos 30 degrees. And then we're taking our time and plugging that in down here for t. 6.3 seconds. Okay, so we get x final is 164 meters. All right. Check for part C. Part D. This keeps going. Just before the projectile hits the ground, what's the y component of velocity? Okay, so we want to find v final y. All right, so now we look at our velocity kinematic equation, right? So v final y equals v initial y plus ay t. So we know v initial y, that's 15 meters per second times sine of 30. Oh, no, sorry. No, this is 30. Okay. So it's just 15 meters per second, right? If I did sine of 30, that's a half. Okay, minus 9.8 meters per second squared times t. So again, this is the same t final, right, that we want, the time when it hits the ground. Okay, so we get 15 minus 9.8 times 6. Okay, so go ahead and plug in. We should get a negative answer. This is definitely bigger, so we get negative 46.7 meters per second. Okay. E is a quickie. E says, what's the final x component of velocity? Well, if we do the same thing up here, right, we have v final x is v initial x plus axt. Our acceleration in the x direction is 0. So the horizontal velocity just stays constant. So our v final x is the same as v initial x. That's going to be 30 meters per second times cosine of 30, which is 26 meters per second. Okay, and then, last but not least, part F, find the angle. So it says, at what angle does the projectile hit the ground? Okay, so we're going to get this by looking, basically just looking at the direction of the total velocity. So we have v final x, looks like this, 26 meters per second. We have v final y is bigger, right? So that's 46, so in the negative direction. So this hypotenuse is V final, and this we could solve for as theta. So I'm going to say theta is inverse tan. Right, so theta is my opposite over adjacent, or tan theta is opposite over adjacent. If I take the inverse of both sides, I get theta is inverse tan 46.7 meters per second divided by 26 meters per second. Okay, so let's plug that into our calculators. We get 60.9 degrees. Okay, so you just want to be specific here. I mean, I did draw the picture showing what how I defined theta, but we could say 60.9 degrees below plus x-axis. Done.